Hi, network engineers. Welcome and let's learn something new today. In today's topic, we are going to learn BGP Confederation. So by the end of this topic, you should be able to understand what BGP Confederation is and also be in a position to configure BGP Confederation. So it's not different. It's not far different with what we configured in our previous practical. That was BGP reflectors. So in addition to BGP route reflectors, the confederation is another method that reduces the number of IBGP connection in an AS. So as I said, it is not different from the route reflector. So a confederation divides an AS into a sub AS. Like when you look at this topology here, we have got our main AS of 200 and it has been divided into a sub AS, that is sub AS 65001, sub AS 65002, and sub AS 65. This one should be 003. So that's how confederation works. So then full mesh IBGP connections are established in each sub AS. Like for example here in AS 65001, you can see the full mesh has been established between switch A, switch D, and switch E, also with other switch B and switch C. So there are benefits for BGP confederations, which are two of them. So the first benefit is that original IBGP attributes are retained, including the local preference attribute, MED attribute, that is the cost, and also the next hop attributes. Then number two, the next benefit of BGP confederation is that confederation related attributes are automatically deleted when being advertised in outside a confederation. So I hope you get that. When you advertise confederation related attributes, they are deleted when they get outside that confederation. So that's the task, guys. That's what we are going to configure. Let's look at our lab scenario. There are multiple BGP switches in AS200. It is required that number of IBGP connections are reduced. So take a note here. In this scenario, ensure that all connected interfaces have STP disabled. If STP is enabled and VLAN if interfaces of switches are used to construct a layer 3 ring network, an interface on the network will be blocked. As a result, layer 3 services on the network cannot run automatically. So even if you set up IBGP peers, they won't be able to establish that peer if you don't disable STP on those interfaces that connect to the BGP peers. So first of all, you should be able to configure the IP addresses on the interface. So in this lab, I'm going to configure switch 1 only for the interfaces specifically, and the VLANs, and add the VLANs to the respective interfaces. For other switches, switch B, switch C, switch D, and switch E and F, I have configured them. So I won't configure them in this practical, assuming that you will be in a position to configure them after I show you how you can configure switch A here. So jump into our switch A, you undo the terminal monitor, then you give that device the name. So this name here, this is switch 1, switch A. So on switch A, we are going to have how many VLANs? 6 VLANs. So VLAN batch 10, 20, 30, 40, and 40, VLAN batch 10, 20, 30, 40, and 60. So create the VLANs in batch. After that, we add the interfaces to the respective VLAN. So interface gig 0/0/1, port link type trunk, port trunk, allow pass, VLAN 60, Then interface gig 2 is also a trunk port, is allowing pass a VLAN at 10. The next is going to be gig 3. Gig 3 is also a trunk port, allowing pass VLAN at 20. The next one is gig 4, being a trunk port, allowing pass VLAN, VLAN if 30. The next one will be gig 5, allowing pass, it's a trunk port, allowing pass VLAN if 40. After configuring layer 2, we now configure layer 3 for communication. So interface VLAN if 60. Give it IP address of 192.168.1.1/24, and VLAN if 10. Give it IP address of 10.1.1.1/24. Then interface VLAN if 20. We give it IP address of 10.1.2.1/24. Then VLAN if 30. VLAN if 30 has an IP address of 10.1.3.1/24. Then VLAN if 40. IP address here will be 10.1.4.1/24. You save. After configuring that, assuming that these other switches also has configuration, so let's come. So you can see it has a device name, so meaning that it has configuration. This is place C. You can see the VLANs have been created with IP addresses. So I configured those before. I wanted to use switch A as a demonstration so that you don't get stuck. After configuring the layer 2 and layer 3, the next thing we are going now is to go to straight away to our main task today, which is configuring BGP Confederation. So we are going to configure the configuration. So we start with switch A. We give it the BGP. BGP here will be for 65001. After that, we must give it a BGP, give it a router ID. So here we are going to use a router ID of we're going to use the loopback. So 172.16.x.x/24, where x here is going to refer to the device number. For switch A here is going to be device 1, switch B device 2, switch 3 device 3, switch D device 4, so on and so forth. On this our switch here, we're going to give it a router ID of 172.16.1.1 because it will be the first one. Then we set the configuration ID. Configuration ID is for the main AS, that is 200. It's that main AS that is going to be subdivided into sub AS that we are configuring right now. So then configuration peer AS numbers will be now 65002 and 65003. That one is on switch B and switch D. After that, we set the peer AS numbers. So peer 10.1.1.2. AS number is on AS number. S number is 65002. That is switch B. Then the next, we create a peer for switch C. So will be 10.1.2.2. AS number here AS number here will be 65003. After that, we are going to advertise those networks. So IPv4 unicast here. That's the network of peer 10.1.1.2. I'm going to tell it the next hop should be the local. Then we do the same to peer on switch C. So peer 10.1.2.2. Next hop here will be, next hop here is local. After that, we are through with setting the BGP configuration on switch A. You save. Then you come to switch B. Switch B. On switch B here, we are going to set the BGP here. BGP here is 65002. Then a router ID here will be a 172.16.2.2 because it is the second one. Now after that, we are going to set the configuration ID. Configuration ID here. ID here is 200 for the main AS. And after that, we are going to advertise the network. So configuration peer AS number here will be 65001 and 65003. Then we set a peer for the switch A. So peer 10.1.1.1 AS number here will be 65001. That is on switch A. Then we quit and save. We create the configuration on switch C. On switch C, this is on BGP 65003. And router ID here will be router ID here is 172.16.3.3, it being the third device. Then configuration ID here is 200. Then configuration peer AS number here will be 65001 and 65002. After setting the configuration peers, now we set the peer on switch A to be 10.1.2.1. AS number here is 65001. After that, you save. When that is done, after creating the configuration with the other sub AS, we are going now to establish now IBGP connections in the AS 65001. So AS 65001 is this AS that carries switch A, switch D, and switch E. We said there's a note that I showed you that you are supposed to disable STP on these interfaces that are going to help us establish IBGP peers. So enter into that switch. So interface gig 0/0/1 STP you disable. Gig 2 you also disable. Gig 3 disable. Gig 4 disable. Gig 5 disable. then we quit. Go to switch D, do the same. So interface gig 0/0/1 STP disable, then .2 STP also disable STP on that gig 2. Come to switch E, do the same. Interface gig 0/0/1 STP disable gig 2 STP you disable. Then after that, we just now create the IBGP peers in this 65001. So now we are going to create the peer. So BGP 65001. The peer here is going to be on switch D. It will be 10.1.3.2. AS number here will be the same AS, that is 65001. Then another peer is going to be set with switch E. So peer 10.1.4.2. AS number here is 65001. After that, we advertise those networks. So IPv4 family unicast. Then we tell it peer 10.1.3.2. and next hop here is going to be local. We do the same to switch E. So peer 10.1.4.2. Next hop here is local. Then you save that, say yes to save. After that, we go to switch D. You do the same, you create the peer, you quit. So BGP here, BGP is 65 BGP 65001. Peer here is going to be the router ID for this device is, before we set the peer, let's give it a router ID. So router ID here will be 172.16.4.4 because it is the fourth device. Now we set the peer to the first peer will be switch A. So peer will be 10.1.3.1. AS number here, they are on the same AS number. On the same AS number, that is 65001. Also create a peer with switch E. So peer is going to be 10.1.5.2. that is on switch E. AS number here will be 65001. After that, we quit, you save. Now finally we go to switch E here, we create IBGP with the others. So quit. So BGP here is 65001. On that BGP, we are going to give it a router ID. On that device, router ID will be 172.16.5.5 because it being the fifth device. Then we're going to create a peer here. We're going to create peer with switch A. So peer will be 10.1.4.1. AS number here, they are on the same AS, that is 65001. Then we create a BGP IBGP peer with switch D. So peer 10.1.5.1 on AS number here. AS number here will be 65001. After that, let's test the IBGP. So display IBGP. You can see the state has changed from open confirmed to open to establish. So display BGP. BGP routing table. Okay, let's give it time. It's still establishing the states. So after that, the next thing we do now, we are going now to configure. We are going to configure exterior border gateway that is on AS100. We are going to establish BGP peer with switch A. So we are going to establish, what I mean here is that we are going to establish a connection between AS100 and AS200. AS200 is the main AS, which have been subdivided into smaller AS of 65001 and 65002 and 3. So we are going to establish a connection between 100 and AS200. So we go to switch A. So switch A here, enter BGP 65001. Then here we are going to establish a peer with a network of 192.168.1.2. It's on that peer is on AS number of 100. Then after that we quit and go to switch F. That is on a different AS number, that is AS number 100. So BGP 100 here. Then AS peer here is going to establish a peer with 192.168.1.1. Then here is on AS number, here will be on AS number 200. That is the main AS. That peer that is on switch the AS number here is on AS number 200. So meaning that AS 100 is supposed to establish a BGP peer with the main AS that is 200. After that, we are going to attach the network, this external network here, this external network of 10.0.1.1. So IP version 4 IP. Before we advertise that, let's give this BGP a router ID. So router ID here will be 172. You can see the BGP state has been established. .1.1.6. So then we advertise that network. So IP version 4 family unicast here. Then we advertise the network here will be 10.0.1.0 mask of as a mask of 24. Display. Now, after meaning that we are through with our configuration, the remaining thing that we are going to do is now to verify what we've done. Was it working? Was it successful? Now we go to verification. So on switch, first of all, display BGP routing table. When display BGP routing table, you find this entry here. of 10.0.0.1.0/24. That is on this external, the external network. Then we go to switch D. On switch B here, that is on AS, on the sub AS 65002. So display BGP routing table. When display BGP routing table here, we can find that external network, that is 10.0.1.0. Our next hop is on switch A, that is 10.1.1.1. Local preference value is 100. As we said, AS number has the advantages that it retains the original BGP attributes, and AS number for that will be 65001. That is on switch A. That is the sub AS. Also, you come to switch D. Okay, while on the same switch B here, we are going to now display a BGP routing table. Then we give it that network of 10.0.1.0 and see. On display that, we are told here the local ID is 172.16.2.2. The S number is 65002. Paths available is 1, best path is 1, and the path that is selected is 1. The routing table entry information of that one is here from 10.1.1.1 on a route ID of 172.16.1.1. The route duration has been 2 minutes, and next hop has not been given. So the relay IP out interface is on VLAN if 10 with the next hop of 10.1.1. You come on switch D, we do the same. So display BGP routing table, and see, when you display BGP routing table, you still find that our network, the network is on 10.0.1.1. that is on the external AS. The next hop will be 10.1.3.1. Local preference value is 100. Then it is on AS 100 here, as you can see, meaning that this guy has established an BGP peer with the external AS, that is external AS 100. While we were on switch B here, we were given here the external AS. It established a peer with AS 65001. It doesn't know about AS 100. This is where the root confederation has worked now. Switch A and switch B has established a confederation peer. Then after that, it is switch A here that is going to establish a peer with switch E. So all devices on AS 65001 here, they will know about the external AS, that is AS 100. So even while on switch D here, you've seen when we displayed, it was telling us AS is 100. Now let's display with that specific route of 10.0.1.0. We got the same results as our previous one. So AS path is 100, origin is IBGP, preference is 100. So that is how you do it. I also come on switch E and C. So display BGP routing table. You see, it knows the external AS of 100, the same network with the next hop being that. So thank you guys. If you found this information helpful, remember also to support our videos by subscribing and also sharing your comment in the comment section below, and also like our video. So let's meet in our next practicals, and goodbye for now.